Hey everyone, Ronak this side. I hope you all are doing well. So let's see the problem of the day. So the problem here we got is numbers of way to assign the edge words part 1. This is problem number 3558. Okay. So basically we are given an array which represents where each subarray represents there exists a undirected and unweighted edge between these two nodes. Suppose here we are given 1 2. Hold on. Suppose here we are given 1 2, so this represent there exists a node between, there exists a undirected and unweighted edge between 1 and 2 node. Here we are given 1 and 3, so there exists edge between 1 and 3. Here 3 4, so there exists edge between 3 and 4. With 3 and 5, so there exists another edge between 3 and 5. So this is the complete tree. Initially, all edges have zero weight. You must assign each edge a weight, either one or two. Okay, basically we have to assign weights to each edge. Edges can be one or two. It can one or two. It also can 1 comma 2. It also can be 1 comma 2. Similar to this, the cost of path between any two nodes U and V is the total weight of all edges between paths connected. And okay, so if we have to calculate if we have to calculate the cost from 1 to 5, we have to add the total weight of these paths while visiting this node. Suppose it has weight 1, it has weight 2, so the total cost of visiting 1 to 5 is gonna be 1 plus 2 equal to 3. Okay, so it is the total cost from node 1 to node 5. Select any one node X at the maximum depth. So, okay, we have to select a node X that is maximum depth from considering this as a root. Return the number of ways to assign edge in the path from nodes 1 to X such that its total cost is odd. Okay, so basically what we have to do, we have to select any path. For suppose we selected this path 135, that's gonna lead to a maximum depth. So here maximum depth is 5. Okay, 5 or 4. 2 has only depth equal to here depth equal to 1, and here these two depth equal to 2. Okay, so we can select any 4 or 5. If we select 4, I mean we have to return the to number of possible ways to I mean assign the weights to the edges such that its total cost is odd. Okay, so basically we are given 1 and 4, and we have to assign weights to these two edges. Okay, so what weight we can assign? We got two edges, so the total sum gonna become odd. Okay, so what we can do, we can do 2 and 1, or we can do 1 or 2. Okay, we can't assign 1 because hence here sum is even. Okay, and 2 2 also gonna return to even. So what we are going to do, first of all we have to find the maximum depth. Okay, so how we are going to find the maximum depth? The simple DFS we are given. So first of all we have to create an adjacent adjacent list. Okay, so for example we are creating adjacent list for this example. So how we are going to create, we are going to just do for first of all, we have to create here if index is starting from 1 to 5. Okay, so here index is starting from 5, so we have to create adjacent of 1 2 3 4 numbers plus 2. Okay, because we are going to leave 0 here. Okay, suppose we created n plus 2, n is 4, so it's gonna of size 6, 0 1 2 3 4 5 6. Okay, so for n I equal to 0, I less than, and I plus plus. What we are going to do is, first let's consider this as, what we are given is an undirected node edges. So what we are given is and u equal to first node of edge, that is edge I of 0, and v equal to second node of that edge, that is edge I equal to 1. And what we are going to do is adj adjacent at u index you have to push back dot push back. I mean basically adjacent to is a vector. Okay. So yeah, it isn't just a simple array, it's a vector that's containing vector. It's a 2D vector of n type and the size of outer is n plus 2. Okay, so you dot push back the v here, we wanna push the v, and similarly we have to connect v to u also, so v dot push back. Since the graph is, I mean the tree is undirected, so we have to connect in both sides. So what it gonna do to our adjacent is, for example, we have zero index from, we have zero index 1 2 3 4 5 6. Okay, so at I equal to 0, this become u and this become v. So at index u we gonna push v, so at 1 we gonna push 2, and at v we gonna push u, at 2 we gonna push 1. Okay, and then at 2 again move to I equal to 1. At 1 we gonna push 3, at 3 we gonna push 1. Now move I equal to 2, at 3 we gonna push 4, at 4 we gonna push 3. Now move I equal to 3, at 3 we gonna push 5, at 5 we gonna push 3. Okay, so that's total code. And after that what we are going to do is, mm, I mean now we have created the adjacent matrix, I mean adjacent list of the all connected nodes successfully. So from this we can also construct a tree, like 1 is connected to 2 and 3. So 1 is connected to 2 and 3, 2 is connected to 1. Okay, 3 is connected to 1, 3 is also connected to 4 and 5, and it's also 4 connected to 3 and 5. Okay, and how we are going to do DFS is, what we are going to store maximum depth here, maximum depth globally. Okay, so word it gonna take node, value of current node, and parent, value of parent node, and the maximum depth, and depth, the current depth, and the adjacent vector. Oh, we need adjacent vector to work on. And so what we are going to do is, first of all, we get max depth. So max depth, we have to calculate the max depth. Max depth equal to maximum of max depth and current depth. And after that, what we are going to iterate over the current, or in what we have to do is, yeah, for int child over adjacent of current node. What we are going to do is, if node is child equal to parent, child equal to parent, we gonna continue else, and if child isn't equal to parents, what we are going to do is again call the, I mean this function dfs. Hold on, we are going to call dfs and now child gonna become current node gonna become parent, and we are going to increase depth by 1. I'm going to pass that adjacent again. Okay, so that's the total code of DFS. So if we want to see the dry run, okay, so let me dry run it quickly. So what we are going to do is first we are going to call at first node. So first node is 1 and parent of 1, let's consider it's 0. Parent of 1 consider 0, and we are going to first call. This is our first call 1 comma 0, and depth is 0, and we have to pass the adjacent. Okay, so I'm not writing adjacent here. So what we are going to, it's gonna check max depth equal to 0. What is the max depth? So current depth is 0 and max depth is 0, so it gonna replace to 0. And for intent child, okay, so basically what was the adjacent of current node is 1 and adjacent of current node is this. Okay, so what we are going to do, I set over every child, that is 2 and 3, and we are going to call 2. So first for 2 is 2 equal to parent, it isn't, 2 isn't equal to 1, so we are going to call over 2. I mean current child is 2, node equal to 1, that is current node, and depth equal to, here we are doing depth plus 1. Okay, depth equal to 1. And after that what we are going to do, we are going to call for 3. So 3, 1 and 1. Okay, because 3 isn't equal to parent node and current node is 1, current child is 3, and depth we are doing plus 1 to depth. Now from stack we are going to call 211. So from 211 the current node is 2, so we are going to iterate over adjacent of 2, that is this. So I mean first child at 2 is 1. Okay, and is 1 equal to parents, so here parents is 1 and child is also 1. Okay, for current node parent is 1 and child is 1, so it is basically redirecting to same, so we're gonna continue it, and now the its loop is over. So we are going to call for 3 and 1, and similarly for 3 and 1, if we see at 3 we got 4 and 5. At now we have to iterate over 3, so current node is 3 and adjacent of current node 3 is 1, 4 and 5. So for 1 we want to continue because 1 is equal to parents, if parents is 1, parent is 1, and child of 3 is also 1, so we're going to continue for 1. And for 4 we are going to call it for current node is 4, parent is 3, and wait, increase the depth by 1. Okay, also for same for 5, current child is 5, current node is 3, and increase depth by 1. Okay, now move to 4. Okay, we finished this, and now move to 4. So adjacent of 4 is 3. Is 3 equal to parents? Yes, so it's finished. Is 5. Okay, max depth is 2, so we have to keep updating it like that. Okay, here we got max depth equal to 1. Here we got max depth equal to 1. Here we got max depth equal to 2. Here we got max depth equal to 2. And 5, 5, 3. So okay, we are going to call over 5. So first child is 3. Okay, and is 3 equal to parents? Yes, for 5 the child is also 3 and parent is also 3. So what we are going to do, we are going to just exit it because we completed it, and now the max depth become 2. Okay, so we got 2 as max depth, so that's how we are going to calculate the maximum depth of the given, I mean tree or whatever the tree, or in this format. Okay, edge formats. And after calculating max depth, for example we calculated max depth equal to 6. Okay, max depth equal to 6. So how many possible ways to, I mean, so the sum gonna become odd? So okay, for 6 we can do 1 plus 2 plus 2 plus 1 plus 2 plus 1. Okay, so what will the sum? 6, 7, 8, 9. So it's gonna become 9. Okay, and there how many ways to choose 6 numbers? Okay, we got first number, second number, third edge, and number here representing is edge, and these are the weights. So first, second, third edge, fourth edge, fifth edge, sixth edge. Okay, so this can have two possibilities, this can have two, this can have two values, 1 and 2, this can have two. Okay, so basically 2 times MD. Okay, well, total possible ways, total possible ways to choose the number of paths. Okay. And now what we have to do is we have to choose the path where the sum is odd. Okay. So for example, we are given if m equal to 3, we are given at 1, 1, 2. So here it's gonna become 3. Okay. 2, 4. Sum is 4 here. Okay. And if we flip any of this, okay, for example, if we flip this, the one gonna become 2. So this gonna become 5. Okay. And if we flip this, so this gonna become 3. So if you notice, if we gonna flip any of this, it's gonna change odd to even. Okay. So the total number of odd, so number of ways, number of ways, number of ways where sum is odd equal to number of ways where sum is even. Okay, so it's gonna become same. So if we got 2 to the power and maximum depth to choose total number of possible ways, total number of possible, choose total possible ways to choose the number of paths, number of to choose the number of weights. Okay, in combination of weights, combination of weights. Okay, so number of ways where sum is odd and number of ways where sum is even. So we need the sum is odd. So okay, we are going to divide by 2. Okay, so we have to calculate the maximum depth, and dividing 2 basically means to the power md minus 1. First we are going to calculate the maximum depth and we are going to return this. Okay, this basically represent odd number of ways to choose, the odd number of ways to assign the weights to the selected path of maximum depth. Okay, to return that, I mean to make that tree possible as per the given question. So let's first write the code. So first of all, we are going to create a vector of that adjacent AD I size plus 2 and for enter equal to main for auto edge in ADES edge. What we are going to do is, for int u equal to AD edge of 0 into v equal to edge of 1 and adjacent of 2 dot pushback v adjacent of v dot pushback u. Okay, dot pushback u. So it's basically going to create the, I mean adjacent list, and what we are going to do is call the DFS on, we're calling DFS on node. So first node is 1 here, parent of 1 is 0, depth is 0. We are going to pass the adjacent list. Okay, after calculating we are going to return power of 2 max depth minus 1. Okay, so what is next step? Column into next depth equal to 0 and void DFS. uh, DFS is int, first is node and parent and int depth then vector vector in by reference adjacent. Okay. After that, what we are going to do is after doing this all, we are going to simply write the DFS, that is this much of code, max depth equal to maximum of max depth comma depth. Okay, and we have to iterate over the node to all auto child on adjacent of node adjacent of current node. What we are going to do is if child equal to parent, if child equal to parent, we can continue, and else what we are going to do again to the DFS where current node is going to become child and parent is going to become current node. Maximum depth is gonna increase by 1 and we'll again pass the adjacent. Okay, we forgot capital D here. That we got text case pass, and if you see here, I mean we have to return in modulo of 10. If you see, I just did, I mean hold on, considered our base is 2 and answer equal to 1, and we just calculated the answer. I mean we are just calculating the power. Okay, multiplying base times answer times multiplying the base. Okay, multiplying to max depth times, and while multiplying we are taking care that it should not exceed the limit of 10 to the power 9 plus 7 by modulus, doing the modulo by the mode we created over. Okay, okay, so here we got the our code submitted. So that's it for today. I hope you like this video. So please make sure to subscribe to Tenzor. Till then, keep smiling, keep coding, and feel free to ask any doubts if you have in comments.